with factoring, looking at the next thing, we've talked about greatest common factor. We've talked about factoring two binomials or a trinomial into two binomials, and we've talked about factoring by grouping, and what we want to do now is look at completing the square, and that is going to be adding something to our quadratic equation to make it easier for us to factor. And when doing so, if we look at one thing I want to talk about is the inverse operations over here. And you know, the things that we do know that we have inverses is multiplication, division are inverse operations. We know that addition and subtraction are inverse operations, and these are two things here that we think about too, is that if I'm trying to get rid of x squared, I would do the square root. Or if I have the square root and I was trying to get to x, I would go backwards and square it. So those are some basic inverse operations as we get started. Okay, now looking here at this first equation, and it is going to be finding the square root. And I have, what are the solutions of here? Going to A, and I have 7x squared minus 10 equals 25. First step, first thing that we're supposed to do is, when in doubt, keep calm and combine like terms. And in combining like terms, I do know that I do have a 10 and a 25, so I am going to go ahead and combine like terms, moving everything to, moving my constants to the other side of the equation. So now I have, that is going to be 35, and of course 10 minus 10, and I have 7x squared equals 35. And go in here, and next thing you know, I want to divide both sides by the coefficient, and I get x squared is going to equal 5, and then doing that inverse operation that we talked about over here, right here, and we know that if I'm trying to find out what x is, I can simply find the square root of both sides, and that will give me x equals plus or minus the square root of 5. And you always, when you're finding that square root, you know that you have a plus or a minus square root, so we can just use that symbol plus or minus to get us what we need. Now looking at B, again, this is you know, a review here, finding these values. So if we go into solving this equation, again, first thing I'm going to do is I am going to combine like terms, and that is going to subtract 9 from both sides. That's going to give me 4 on the left-hand side. Of course, 9 minus 9 zeroes out, and I have 2x squared. As soon as I get my variable isolated like that, I always want to divide both sides by 2, or divide both sides by the coefficient, which is 2 here. That's going to become 1, so I have x squared is equal to 2. And again, finding my square root, because that is going to cancel those things out, I end up getting x equals plus or minus the square root of 2. As I continue on with solving, I'm going to do this little word problem here, and it is determining dimensions, and it says the length of sides of a rectangular window have a ratio of 1.6 to 1, and the area of the window is this. What are the window dimensions? Well, let me do a quick drawing. Okay, so there's my window. I got Isaac Newton there sitting underneath an apple tree in front of his house. But it tells me that this window is a ratio of 1.6 to 1. And it doesn't tell me what the ratio is, so given this unknown ratio value, I know that that would be 1.6x to 1x. Okay, so I know that I'm looking for the area of this window, and I know that the area equals length times width, and I determine that my length is going to be 1.6x, my width is x, so I've done a little bit of substitution in here, so my length and my width, and then I substituted an area that they gave me in the initial problem, which was 2,822.4 inches squared is going to be equal to my length times width. And now what I need to do is start isolating my variable. So I am going to divide by my coefficient on both sides, and then I know that I'm going to have x squared equals 1,764, and then I am going to find the square root of both sides, and of course now x is going to equal plus or minus 42. Well, if I'm dealing with length, I know then that that should only be a positive length, not a negative length, so x is going to be equal to 42. All right, so we have x is equal to 42, and we're going to remember our units. It's going to be 42 inches. Now, going back here, so we know that my width here? My width is equal to 42 inches, and then that makes my length is going to be 1.6x equals, well, 1.6 times, we said x is equal to 42, and that is going to give me 67.2 inches. So that is going to be my length. All right, now looking at this next example, solving a perfect trinomial square. Well, if you recall a perfect trinomial square, if we factored a perfect trinomial square, that's what we're going to do here. So I look at this side over here, and I hope you can recognize that that is going to be, if we were to factor that, that would be x minus 7 equals 25. And then, of course, that can be written as x minus 7 squared equals 25. And now what are we going to do? We're going to solve. We want to isolate. We want to isolate that expression, the variable. Well, and we have to get rid of the exponent in order to get that variable by itself. So we've talked and we said in order to get rid of that squared value, we would find the square root. Now, in order to find the square root of one side, of course, we have to find the square root of the other. Now, in doing so, we know then that that thing, my square root sign and my squared is going to equal each other out, cancel each other out, become 1. So then I have x minus 7 is equal to, we know that the square root of 25 is going to be plus or minus 5. And if I combine like terms now, move my 7 over to both sides, and I know that x is going to be equal to 7 plus or minus 5, which is x is equal to 7 plus 5, and x is equal to 7 minus 5, or x is equal to 12 and 2. So again, isolating that variable, working it down, getting rid of your factoring, getting rid of your exponents, combining like terms, and making sure that you have a plus or minus here, and working out two individual problems. And if we to the next section that we're working on, we're talking about completing the square, and now here that is looking at this problem. Look at our A, B's, and C's, because that's going to come into a issue or come into usage here. Okay, so looking at the standard form of a quadratic equation, we have ax squared plus bx plus c equals 0. So here, that's what we're going to look at when we're completing the square. Look over here, I got the value of a is 1, the value of b is going to be 6, but we do not know the value of c right now, and that's what we're trying to calculate to complete the square. So we're going to rewrite it in standard form. Well, it's in standard form now, and we're going to complete the square by adding b divided by 2 squared. And by completing that square, we are going to take half of b, which we said b over here was 6, so 6 divided by 2 is, you could have just said 3 squared here, which is equal to 9, or of course we just, understanding the math operations, I have 6 squared over 2 squared, which is 36 over 4, which is equal to 9. And then I'm going to, in this case, rewrite this formula because it just asked me what that value is. Well, the value is 9 that I need to add, so I'm going to rewrite that as x squared plus 6x plus 9. So adding 9 to that allowed me to complete the square. In solving this now, we will use this to complete the square. So what I'm going to do is I'm going to, on this next example right here, I'm going to move my variables to one side, my constants to the other. And let's see, combine like terms. Okay, so I've gone and combined like terms. I've moved my constants over to the right. I've moved my variables over to the left. And one thing I do need to make sure that I do is, in order to complete the square, my a value, the coefficient of x squared, needs to be 1, so I can go ahead and do some simplifying down here, and this will divide everything by 2, so I have x squared minus x equals 3. And we're going to go ahead and do that half of b squared, and we're going to add both of that to both sides here, so we know that b is -1. Half of that squared is going to give me 1/4. All right, so I've gone and I've added I've added this value to both sides, and then it says factor the trinomial. Well, here is my trinomial, and that will factor out to x minus 1/2 squared equals, what do I get over here? Goodness, how about 13 over 4? And now when I go ahead, I need to, of course, find the square root of both sides. So I have x minus 1/2 is equal to plus or minus the square root of 13 over 2. Which, we know this is equal to the square root of 13 over the square root of 4, which equals the square root of 13 over 2. That's how I came up with that answer. And now we just simply combine like terms, and we end up with plus 1/2 on both sides, and then x is going to be equal to 1/2 plus square root of 13 over 2, or 1/2 minus the square root of 13 over 2. All right, as a reminder, on this next one it says writing in vertex form. Well, that formula right here is my vertex form, and that looks very similar to the problem as I'm completing the square. So we will go ahead and write this in vertex form, and it wants to know what the vertex form is and then name the vertex and the y-intercept. Well, y-intercept, we know that -6 is the y-intercept, so my y-intercept is going to be 0, -6. That portion of the problem is done. But in order to get vertex form, we're going to have to do completing the square. So we have x squared plus 3x is going to be equal to, when I move my -6 to the other side, it becomes a +6. And we know that we take 1/2 of b, and b is equal to 3. So we are going to take half of b squared and add it to both sides. And we're going to factor now, and we have x plus 3/2 squared is going to be equal to, All right, so we have the right-hand side is going to be 6 plus 9/4, which is going to be, in order to add a fraction, we're going to have to change them both to common denominators. So we get 24/4 plus 9/4, which is going to give me a 33/4. So I can go ahead and, that's the wrong button. I can go ahead and just, I'm going to write that in now as 33/4. Now solving for x, I find the square root of both sides, and that leaves behind x plus 3/2 is going to be equal to plus or minus the square root of 33/2. And then we go ahead and subtract from both sides and simplify, combine like terms. We'll see what we got here. All right, I found out what x is equal to, but it did say name the vertex. Well, if we go back, my bad, and we go back to this point right here, and I have x plus 3/2 squared equal to the square root, oops, don't even need that, 33/4, and I'm going to go ahead and subtract that from both sides to get into the vertex form, and bring that over here. I have x plus 3/2 squared minus 33/4, so my vertex is going to be equal to negative 3/2, negative 33/4. Remember, your h and k values are what drive your vertex.